Good evening. Today, I will be discussing a recent public lecture given by the esteemed Sean Carroll on the nature of entropy, the arrow of time, and the origins of the universe. Dr. Carroll started the lecture by discussing the nature of time, in that it can be used as a means of identifying a location, similar to spatial coordinates. This is why time is sometimes referred to as the fourth dimension. Dr. Carroll explained that the universe, as we perceive it, follows a sort of arrow of time, constantly propelled forward, causing aging, our ability to remember the past, but not the future, and a phenomenon not often discussed by professionals, but boldly put forth by Dr. Carroll, the Benjamin Button effect. From there, having established that time moves always forward, we moved into discussing the nature of entropy, the tendency of an environment to naturally become more and more disordered. In a truly excellent example, Dr. Carroll demonstrated just how he felt entropy worked, constantly edging onward from the beginning of time into the end. This, of course, rationally explains the origin of the universe, as all matter and energy was briefly incredibly organized and compact before the Big Bang, followed by a long and drawn-out process of dissipation across the universe, forming planets, stars, and the universe as we now know it. However, the universe as we now know it is not the final state of being, argues Dr. Carroll, as the entropy of the universe constantly increases. The Earth itself is a major player in this process, as it was explained that for every photon we receive from the Sun, we, the Earth, put out 10 photons, each with 1/10 of the energy. Dr. Carroll then went on to show that the eventual state of the universe, in an exceptionally long period of time, is when only black holes would remain. But this too was not the end, as it has been evidenced that black holes themselves leak radiation, until the entire universe was a thinly spread out arrangement of particles and of equal energy. Dr. Carroll also briefly discussed pocket universes, which arise from irregularities in space-time. The larger the irregularity, the less likely it is to occur, eventually returning to its natural entropic state of disorder. In the interest of setting myself apart from the hundreds of other students who procrastinated in getting their final bucket points, I'd like to educate you all on a bit about probability. Now, one of the key arguments when it comes to entropy is that since the proportion of equivalent disordered arrangements is so much greater than the number of ordered arrangements, entropy, on average, will decrease or remain the same. This argument, though compelling, is not without its flaws. Allow me to elaborate. Although the current universe as a whole is becoming gradually more disordered, that is only because there exists within it a certain amount of order. If we consider the final state of the universe, as stated by Dr. Carroll, in which a totally perfect entropic state exists, any other arrangement that the billions of trillions of particles in the universe make would have less entropy, if only for a moment, than how it just was. Therefore, the potential for a decrease in entropy is higher. What's more, since we consider entropy to be controlled only by matters of probability over an infinite period of time, since we assume the universe itself does not end, although the entropy will continue to increase and we'll all die, over an infinite period of time, every possible sequence of events must happen, regardless of how improbable they are, including the complete restructuring of the universe as we know it. Thank you, and good night.